All right, guys, so we're on to 5.4, which is now ellipses. So let's define what an ellipse is. Given 2 points F1 and F2 in the plane and a fixed distance D1 or D, an ellipse is a set of all points x, y in the plane such that the sum of the difference from F1 to xy and the distance from F2 to xy is D. So no matter what xy on there, your D1 and D2 added together will be the same thing. Now, the F1 and the F2 are what we call foci. The difference, let me summarize this really quickly before we do more vocabulary, is a circle would have all of the same radius, right? The same distance from the center to our actual circle itself. For an ellipse, you'll find that they're not the same distance, horizontal, vertically, okay? So let's go over some vocabulary that helps us with this. The center of the ellipse is the midpoint of the line segment containing the 2 foci. The major axis of the ellipse is the line segment connecting, announcement. Sorry, guys. Okay, the major axis of the ellipse is the line segment containing the F1 and F2. So as you can see down here, this is the major axis, where the minor axis is the line containing the opposite, okay? So make sure, because this can switch at any time, and it will show you on the other paper what that looks like. Here we go, the vertices. So we'll also be saying vertices. The vertices of the ellipse are points on the ellipse in which lie on the major axis, okay? So your vertices, okay, major axis, V1 and V2, okay? The co-vertices are the points on the ellipse that are on the minor axis, okay? So again, these can change depending on how your ellipse looks, and this will be shown down here. I'll point this out down here. So an ellipse can look as if it's horizontal, but it can also look vertical. So that's where your major and your minor changes. So be careful when you talk about your vocabulary, okay? So this is just in general. If we have an ellipse at 0, 0, you see in this case, because it is a horizontal right there, that our major axis is horizontal, our minor is vertical. That means negative A, 0, and A, 0 are F1, F2. No, never mind. Negative C and C is our F1, F2. Negative A and A is our vertices. B and negative B are our co-vertices. So in a standard equation of an ellipse, this is what it looks like. We have x squared over a squared plus y squared over b squared equals 1. Okay, a couple of things to keep in mind. This will always equal 1. Okay, a will always be under x, b will always be under y. Now you'll see in the future that if a is greater than b, then we have your horizontal ellipse, is what I'll call it. And if b is greater than a, we have our vertical ellipse. All right, let's see what else for notes that they give us. The values of a and b determine how far the x and y direction. Okay. Respectively, 1 counts from the center to arrive at the points of the ellipse, right? So if this was 5 squared, it would be 5 away on the x, or the horizontal part of the ellipse from the center. Same thing, B is the vertical part. So some notes to keep in mind. If A is greater than B, And then we have the horizontal. That's what I was pointing out. The major axis is horizontal, and the foci lie to the left and right of the center. In this case, the distance from the center to the focus can be noted by c equals the square root of a squared minus b squared. So keep in mind, a is greater than c. So to find the distance from the center to the focus, we say c equals the square root of a squared minus b squared. Okay? Just as on the next page, if it were the other way around, and we had b is greater than a, then to find that distance, you would say c equals the square root of b squared minus a squared. In other words, guys, just keep the bigger value in front, okay? Which again, this is what I just pointed out, bigger minus small. All right, what can we do from here? Well, let's do some graphing. So we're going to identify the center, the vertices, the foci of the ellipse, and then graph. So first thing I want to point out that this does equal 1, so we're all set there. The center is coming from what's added and subtracted onto x and y, just like our h and k in past lessons. So in this case, our center is 0, 0. Okay, so I'm going to graph that first so I can keep track of things. Now, what I want to point out is a squared is 16, right? Because it's under x squared. And b squared is 9. So if I were to solve, that means a is 4, b is 3. Okay, so what that means is a is the horizontal part. So let me get another color so you guys can see. A is 4 away from the center. So 1, 2, 3, 4. 1, 2, 3, 4. Now B is what we do vertically. So 1, 2, 3. 1, 2, 3. Now, this is where most students make a mistake because they're not identifying the correct axes. So A is greater. That means our major axis is horizontal. And because it's horizontal, that means the foci are on that horizontal one, not on the vertical. Now, to find the distance of the foci, to find where the foci is. So distance of foci. So remember, that's from the center. That is c equals the square root, and it's our larger one minus our smaller one. So we get 16 minus 9. 16 minus 9 is 7, so we get the square root of 7. Okay. What that means is that our foci is the square root of 7 from the center. So square root of 7 is about between 2 and 3, right? So between 2 and 3, so I'm just going to estimate it right there. Now, because the question wants you to put down what the foci is, we just know since it's 0, 0, that it's going to be square root of 7, 0, negative square root of 7, 0. Okay, remember, this doesn't exactly give you the foci, it gives you the distance from the center. It just happens to be, since our center is 0, 0, comes out nice and easy. And then, of course, if we graph this and we put it together, I'm not always going to make the best ellipse, but I'm going to try. And you can see that this ellipse is horizontal. All right, let's continue, see if we can get more questions. Here we're going backwards. We're finding the standard form of the equation of the ellipse that has the vertices positive and negative 8 there, and then the foci. So just like we did in the last section, when we're given information, we might want to see what it looks like. So let me graph, make a sketch. Be careful on your XY coordinates, okay? So the vertices, and I'm going to label them, are 0, positive 8, and 0, negative 8. So this is V1 and V2. Now, because the vertices are vertical, right, that means our major axis is vertical, okay? Which also means that B should be greater than A. Let's see, our foci is 5 and negative 5 there. Okay, I know I'm a little off with my graphing, but okay. Remember that the center is going to be the halfway distance. So if you see right here, our center is 0, 0. So right away, I have x squared over something plus y squared over something. And remember, it equals to 1. Now, how do we find a squared and b squared for us to actually put that underneath? Okay, well, first of all, the distance of this vertice is 8. And if you remember, the vertical vertice is under the y value. It's the b value there. So, and we have to square it. So 8 squared is 64. Now, how do we find the a squared? Because we have nothing on this graph that indicates anything. But we do have an equation that has a squared in it. And if you look, it's that c equals the square root. Now remember, we're talking about it's your larger one minus your smaller one. Our larger one in this case is the vertical, which is that 64, minus our a squared. Okay? We have 2 variables to solve. We need 1. Well, we're trying to find a squared, so we must have c somewhere. C is the distance of the foci from the center. Well, the foci is 5. The center is 0, so C must be 5. And now we can solve. Square both sides. You get 25 equals 64 minus a squared. We end up getting a squared equals 39. Now, yes, it's very tempting to take the square root of both sides, blah, blah, blah. Yes, but what was our goal of the equation, of the question? It was to create the standard form of the equation. Do we need a or do we need a squared? We need a squared. So right there in our a squared spot, we get 39. So just keep in mind how far you guys have to go. All right, next one. Now we're going to talk about what if our ellipse is not at the center, 0, 0, and how does that affect how we solve for things, okay? So again, HK is our standard form of a center. Think of the opposite. So if we look at example 3 here, it says identify the center. So right away, the center is -1, 2. I'm going to graph that, -1, 2. Okay, and there's my center. Now, the lines which contain the major and minor axes, the vertices, and the endpoints. Okay, so we have a lot to make sure that we identify. All right, first of all, let's see what information we can get here. We have a squared equals 9, and b squared is 25. So of course that means a is 3 and b is 5. Now remember what that means. That is the distance from the center, okay? So I'm actually going to label these in different colors. So I'm going to do the A. A is horizontal, is 3 away. So 1, 2, 3. And on the other side, 1, 2, 1, 2, 3. Okay. And then B, let's see if I can get, oh, I'll get this green, is 5 away. That's the vertical part. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so the major axes, remember, which is the longer part, we want to say is the vertical part, okay, which also gives us our vertices. In those points, it looks like it is -1, 1, 2, 3, 4, 5. Nope, I meant 6, 7, right? Because that's 7. And then the other vertex is -1, -3. The minor axes, which is our co-vertices, okay, that is going to be 1, 2, 3, 4, -4, 2, and 2, 2. Okay. All right, got that, got that. Now let's do the foci. Remember the foci, first we have to find the distance. I'm labeling it so you don't forget, this is not the foci itself, it's the distance of the foci. So C equals the square root, it's the larger one, right? So 25 minus 9. 25 minus 9 is 16. Square root of 16 is 4. So remember, the distance is 4. So let me get my blue marker here, and I'm going to go 4 on the major axes. This is where people mess up. They automatically want to go horizontal. You want to go on the major axes. Our major axis is vertical. So I'm going to go 4 from the center. 1, 2, 3, 4, and there's foci 1. 1, 2, 3, 4. There's foci 2. So it's -1, 6, and -1, -2. Okay. And then of course on our graph we could put this together if we absolutely had to. Of course I can't draw. Okay. Awesome. All right, now let's do it again. Let's find the equation given certain things, okay? So first thing I'm actually going to do is make sure that we graph what we have already. And also identify, label what we have. So we remember, is it on the ellipse or is it inside? So here's my X and Y axes. Foci, remember, foci comes from the major axes. Okay. Now, vertex is one vertex, which means there's another vertex. Again, this is on the major axis. Okay. So 2, 1 is a foci, and I'm going to label that as F. Then we have 4, 1, so 3, 4, 4, 1, that's a foci. And then we have 0, 1, which is a vertex. Okay, let's talk about this. Remember that the center is in the middle of the foci, okay? So I'm just gonna label this right now. That in between the foci is the center. And that should automatically tell me that if we have the vertice on the left side, we are missing the vertice on the right side. Everybody see what I'm getting from the information provided? Okay, so we need our equation, right? The first thing we're going to do is find our center. Our center is the distance in between the foci. So we could probably actually do the midpoint between these two foci. To find the midpoint, you would take 2, 1. So let's label this for future notes, okay? So these are midpoints. So midpoint between foci. Okay, so how do you, I'm going to do this even though you guys can see where the center is. I'm going to do it algebraically so we know in the future how to do that. Remember, it's your x values added together divided by 2 and your y values added together divided by 2. So our center in this case is 3, 1. Okay, where does that start us off in our equation so far? So remember, we do opposite. So it's x minus 3 squared over something, or a value, plus y minus 1 squared over something equals 1. Okay, this is, since our vertice is horizontal, that means our a value is larger, and we can find our a value, right? Our a value is the distance from the vertice to the center. Well, our vertice is 3 away. So a is 3 away. I got that from vertice to center. Okay, I'll put center since the is used with foci. Now, of course, do we put that 3 under there? No, because it's a squared. So 3 squared is 9. All right, as you can see from our diagram here, our B is our vertical distance away from the center, but we don't know that. We just know it should be less than 9. Well, how do we find that? We find it from the distance of the foci. Okay, so distance of foci, and the distance of the foci is from the center, right? So as you can see, from the center to the foci is 1, and then we're going to set that equal to the square root. A comes first because it's larger, so 9 minus b squared. Now we're going to solve square root. We square it, so 1 equals 9 minus b squared. So b squared equals 8. Do we have to go further? No, because in our equation we need b squared. So our answer is this equation here. All right, what else can we do here? Right. Oh, we've got to complete that square. So just like we did it with the circles and everything, we're going to find the standard equation of an ellipse by completing the square. Okay, remember with our parabola, we only had an x squared or y squared, one of them. With our circle, we had x squared and y squared. So in this case, you then see again x squared, y squared. The difference between the circle and the ellipse is that the ellipse is going to equal 1. So when you're completing the square, if we get 1 on the other side, or if we want it to be ellipse, you need 1 on the other side. So that's where it goes back and forth. So let's see how we do here. It says put the equation in the standard form and then find the center, the vertices, and the foci. Okay, so let's look at this. We need to put our x's together, our y's together, and our constants on the other side, okay? So I get x squared minus 2x plus 4y squared plus 24 equals 24y, equals negative 33. Okay, what I want you to keep in mind here is this 4y. Remember, that has to come outside of the parentheses. So I have x squared minus 2x plus 4 times y squared plus 6y. Now we go to complete the square to make those perfect squares by, remember, it's b over 2 squared. And I'm going to underline that so we know whatever we do to one side, we have to do to the other. So we get x minus 2x plus 1, and that's what we're adding in there, plus 4 times y squared plus 6y plus 9. That's what we're adding in here, equals. Now be careful, guys, because yes, on the right side here we have a negative 33. Right here we're adding in a 1. Whatever we do to one side, we do the other. But here, be careful. Are we just adding in a 9? No, we're adding in 4 of the 9s. So we're actually adding 36. Okay. All right, so let's simplify this. Let's complete our square. So we have x minus 1 squared plus 4 times y plus 3 squared equals 4. Okay, what I want you to do is go back to what our equation looked like for our standard form. And I want you to see if you can predict what to do next. Okay, so this is our equation. What do you notice is a little bit different here? Well, what did I say? This has to equal 1. The other thing to keep in mind here is that we know we have to do something because the value here is 1, not another number. Okay, so what we're going to do now is divide everything by 4 to get rid of that 4. So if I divide both sides by 4, I get x minus 1 squared all over 4 plus, if I divide this by 4, I get y plus 3 squared. Now, of course, that leaves me with 1 in the numerator. And on the right side here, 4 divided by 4 is 1. So now you can see it is an ellipse because we have the addition, it equals 1. Now we have our A and our B. Okay. Of course, I'm running out of room, right? So I'm going to see if I can put things up here. So the center of this ellipse is 1, negative 3. So let me write that down. 1, negative 3. Okay. Our A squared is 4. B squared is 1. So A is 2. Sorry, I forgot to take the square root. B is 1. That means it's going to be a horizontal ellipse. So 2 away, horizontal. 1, 2, horizontal. 1 vertical. This is a tiny ellipse, huh? Okay, and then the foci, remember, is the distance. distance, just so I keep that in mind. C equals the square root, and it's going to be 4 minus 1. So C is the square root of 3. Now, when we have to write these coordinates, remember it's square root of 3 away from the center. So when you label these points, what I would do is start with the center. So the center is 1, comma, negative 3. I know I have to add and subtract from the x value in this case of the center because it's a horizontal ellipse. So I'm going to add square root of 3 and subtract square root of 3. Now, if it was a vertical ellipse, I would add and subtract from the y value of the center. Okay, now it did tell me to label the vertices. So as you can see, it was 2 away from the center. So that would be 3, negative 3, and negative 1, negative 3. Okay, just making sure we get all those points of what the question was. Okay. Eccentricity of an ellipse. Well, think about it. Eccentricity, and of course I'm going to say it wrong, right? Think about it. It's the electricity of it. Okay, so how much you stretch it out compared to bring it in, and it becomes more of a circle. Here, it's becoming more and more of a linear graph, right? Where this, if we bring it in, it becomes more of a circle. And so eccentricity is looking at that part, okay? It's the roundedness of our ellipse. So what we can do is the eccentricity, okay, is the distance from the center of the focus over the center to the vertex. It's the ratio of it. That tells you how close it is to a circle compared to that line. So in general, the closer it gets to 0, the more circular it will appear. So if the ratio is closer to 0, it will appear like a circle. If it's closer to 1, then it's flat, like that line that I've been saying, okay? So here's what we're going to do. We're going to find the equation of the ellipse with these vertices, but specifically we have the eccentricity, okay? So what does that mean? Again, if we're going backwards, I want to see what's given to us so far. So if I have my xy coordinate, I know that my vertices are at negative 5, 0, and 5, 0. So these are my v's. Okay. Now, I want to keep in mind that that also means that my center is at 0, 0. And that also means that, okay, this is the horizontal, right? So that means my A is 5. Okay. Now, A is 5, and that A is the distance from the center to the vertex. Okay, it could be B. So this A here technically could be a B value depending on the axis, major axis, okay? So I can start filling these in. So E equals 1/4. So I know 1/4 equals that center to the focus, which is C, all over that distance from the center to the vertex, which in this case is 5. Knowing I have one variable there, I can solve for it. So if I do my algebra out, I get that C equals 5/4. Okay, Now, C is that distance, right? From, so foci, whatever that is, okay? So that means I can find my B value, right? Now that I have my distance. So 5/4 equals the square root. Now I know the A squared comes first because it's a horizontal ellipse. So it's going to be 25 minus B squared. And then I can solve. I get 25/16 equals 25 minus B squared. I end up getting, don't forget your fractions. If I were to subtract 25 from both sides, I need common denominator, all that stuff, or you can use your basic calculator. Don't forget though to put it back into a fraction because that will help, okay? So we get B squared equals, is that right? I just want to check my calculator. Sorry, I have my notes down, but I just want to make sure. Okay, so that gives me 375/16. Okay, now what does that mean? Okay, let's put this in. We know that the center is 0, 0, so we have an x squared plus y squared. We have equals 1, and now we have all over 25 all over 375/16. And I would keep it like that, guys. Sometimes they might have you, remember dividing by a fraction is the same thing as multiplying. They might have that 16 up here. But knowing that we would like to keep it in the form of our A's and B's on the bottom and not have to worry about that, keep it just like that. Okay, almost done. Applications. As with parabolas, ellipses have a reflective property. If we imagine the dashed lines below representing sound waves, then the waves emanating from one focus reflect off the top of the ellipse and head toward the other focus. This is used to construct a so-called whispering gallery, so having the echoes and stuff. If a person whispers at one focus, a person standing at the other focus will hear the person as if they're standing right next to each other. Kind of crazy how physics works. Okay, so let's do this. Last problem. Shauna and Spencer want to exchange secrets from across a crowded whispering gallery, which is a room having a cross section that is half an ellipse. If the room is 40 feet high at the center and 100 feet wide at the floor, how far from the outer wall should each of them stand so that they are positioned at the foci of the ellipse? Let's draw this out. So we have a room that is 100 feet. Okay? So let's have our center be at 0, 0, just for simplicity, right? So we have our walls that are half an ellipse. We know that the height from the center here is 40. Okay. We know that this distance is 50. So that's great, right? Because then we have our A and we have our B. So what we want to find is where they have to stand, right? So where Shauna and Spencer have to stand. Well, where they're standing is that distance from the center of the room, which of course we know is the value of C. And C equals the square root of our larger side, which is 50 squared, minus our shorter side, which is 40 squared. That means C equals 900, or C equals the square root of 900, so C equals 30. So they should stand, 30 feet. Now remember what this means, 30 feet from the center of the room. All right, guys, make sure you analyze what information is given to you, what you need to find, and the different ways to get